it gets moved. Okay. So when you picked up your paper off the stand today, you had a bunch of pre-images on it before you did anything to the figures. They were all pre-images. Okay. And then you did some things to them, and your final result is the image. So this would be the figure after it's moved. You kind of have a before and after picture, like an info commercial. You know, like I know there's one right now. There's like some cream that you can put underneath your eye and it gets rid of your wrinkles or something. And they always show like a close-up of before and after. So this is what we're doing with our shapes, before and after. Okay. There's 3 things that we could do to them that you did on your paper. Translation is the noun. The verb is translate. And that's when you slid the figure. So this is a slide. So here's the high school word, translation, and the elementary school word was slide back in 2nd, 3rd grade. Reflection. In elementary school, you called that a flip. And then rotation, back in elementary school, you called that a turn. And you just did all 3 of those on your sheet, right, with the patty paper. Okay. Now, if you look at all your pre-images and all your images on your sheet, you'll notice that they are all congruent figures, right? The pre-image is congruent to its image, better known as congruent figures. And because of that, all 3 of these are what's called an isometry. An isometry preserves distance. They're congruent, they're the same size, same shape. There is one other transformation that is not an isometry, and that's called a dilation. Like if you go to the eye doctor, you go in, your pupils are a certain size of your eye, and then they do this thing called dilating it, which means what to your pupil? Yeah, it gets bigger. Okay, it's still your same pupil, right? They're similar figures. Okay, it doesn't preserve distance. So even though a dilation is a transformation, it's not so special as an isometry. Okay? Alright, so if we're going to go on your paper and we're going to go through and we're going to write down the high school words for each one of these. Okay? That's on the right, yeah. Okay, so on number 1, we have this figure drawn, and those are the coordinates. Right? And so we have some notation that we have to talk about, and these are all just translations today. All week we're going to be doing one individually each day. But today we're doing translations. We have this kind of weird notation up here. Okay? X, comma, Y, and then that means we're going to take every single point down here, and we're going to move it in a certain way. What do you think would happen if I add 7 to every single X coordinate? Which way do you think it would move? To the right? So what this says is I'm going to move every single point to the right, 7. And this tells me, which way am I going to move, do you think? Up, because it's plus 3. So we're going to move up 3. Every single point. Now it is graph, so we could just count. Okay? So let's do that. We're going to take every single point. I'm going to start with Q. And I'm going to move 7 to the right. 4, 5, 7, and up 3. And that's going to be my new point, Q prime. Now they do put little, it's called prime, but it looks like a 1. What that means is it helps you distinguish which figure was the pre-image and which one was the image. Okay? So the one that I have in red, the Q prime, is the image point. The one that's in green is the pre-image before it got moved. We do the same thing to B. So 7 right. And up 3. And if I do that correctly, it's a translation, so it has to preserve distance, which means that the pre-image and the image have to be congruent figures, same size and same shape. Everybody a minute to graph theirs, and then we're going to talk about these ordered pairs, okay? 0 plus 3 would give me 3. And if you check on my graph, it should be consistent that it would be at 1, 2, 3, 1, 2, 3, there it is, 3, 3. Then if I do B, negative 3 plus 7 is at 4. And then 1 plus 3. So 4, 4 is where B prime should wind up. And we can continue to do that. Negative 2 plus 7. Negative 1 plus 3. Negative 4 plus 7. Negative 3 plus 3. So you could get the ordered pairs without having to necessarily do all the graphing and counting. Okay? All right. So we have about, what time we get out here? Like, we have almost 20 minutes. You have 12 problems on that sheet. What you don't finish is homework, but most of you should be able to finish before you leave today. Okay?